Hello again. Uh, this is the latest version of the 3D area scanners I've been working on. This one's based off the RPLidar module, the A. And this is a BeagleBone Green wireless as the controller for it. Next to it's the TMC 2209 stepper motor controller. I like these a lot better than the older ones. They're very quiet. And right now I'm just using it in legacy mode. You have the ability to communicate with this in UART or maybe even SPI mode, but it's just behaving like a normal stepper motor driver. Below it, a buck voltage regulator, so I've been using the DeWalt lithium battery, 20 volts. That buck transformer or regulator just drops down to 5 volts for the BeagleBone and the RPLidar module, and then it gives us 20 volts to the stepper motor itself. And so, kind of while we're talking with this, I'll get this thing plugged back in. So, the scanner itself printed out of PLA. Sometimes it's worth doing the base and ABS, just because the stepper motors can get a little bit warm if you're not careful with your setup. And if they get warm, then they'll start to distort and you'll lose belt tension, start to skip. And so for the battery module, it's pretty crude, but perhaps you can see inside here I have a couple of copper teeth in there for the battery. Those are actually pieces of copper pipe that is hammered out flat and then pushed through the battery support module, and then soldered them into the wiring for the controller. So while we're talking with this, I'll get the battery in. And we'll get it fired up. And so for the Z-axis rotation, it uses a 0.9 degree stepper motor. It's a NEMA 17 body size. I put some heat sinks on it. Once you have the stepper motor driver set up, you know, your V-reg set to maybe 0.6, 0.7 volts, you get some pretty good results without generating a lot of extra heat. You don't need a lot of torque to drive this. Just make sure that you have enough to overcome the stepping of the sides and maybe a little bit of binding in the pivot. There's nothing fancy inside the rotation itself. It's just all PLA, a bearing, a guide, you know, a 128 2 sprocket. The BeagleBone Green takes a little while to come up in Wi-Fi, so you'll see a little white or blue LED light up here that'll signify that you're basically ready to connect. There it came on. And then I really struggle with this part of it, but this is an angle sensor, and attaching a magnet to the stepper motor driver was not an easy task. Took a lot of tries to get it right, and I spent a lot of time working on the communication with the sensor itself. And one of the perhaps most difficult things is that since the motor is geared to extra rotation, so every time that the scanner goes around one time, the motor goes around 8 times. So in order to deal with that rollover of the sensor, and I've been playing with the wiring on this so much that I've actually kind of wore out the female pins on the BeagleBone, so I had to kind of improvise something in there, and you can kind of see the unfinished wiring there, but that's the clock signal to the sensor. And it looks like we're online. So the functionality wise, this thing rotates, the scanner rotates and scans. The RPLidar module grabs 4,000, 8,000 points around. Actually, the fewer points you scan with the RPLidar in the kind of like the vertical plane, the more accurate it seems to be. So you don't really need speed for that. And one of the benefits of the way it's designed is that it's internally it's similar to what I have here with a angle sensor on either on the motor or on the rotation of the device itself. So every time it goes around 360 degrees, it resets and it captures that data and sends out. But there's a little bit of randomness about when it actually starts, so the sensor gives different values for each time it takes a scan around. So if you scan it one time around and get 4,000 spots, every degree that it scanned at is different the next time it scans around. So if you scan in one spot 4, 5, 6 times, you can generate a great number of points in that plane. And then the z-axis just increments every time we're done with that process of scanning with the RPLidar. So right now I have it set up so you can change the parameters, but I have it set up so that there's 6,000 counts on the z-axis, so it's incrementing 6,000 times around for a full scan. And then the number of scans around could be one time around capture data 4,000 points, or 16,000, whatever you want. And then of course the more points you grab, and the higher number of points to scan the z-axis, the longer it takes. So functionality wise, I probably really should do a separate video what I'll show next. But I'll bring you over to the PC and just kind of show you